Today we're going to start section 6.3 and we're going to be looking at logarithms, common logarithms and natural logarithms. And these are inverses of e and exponential functions. So they're opposites of each other. So first take a moment, open up to your journal, page 166, and copy down the definitions. Next, let's look at the core concept. In the core concept here, we can see this log is the opposite of this exponential form. And you can see the base b is dropped a little bit lower here, and then we have the regular base here. The exponent is what a log will equal. So logs equal exponents. Now, one thing we're going to practice is switching writing form to form. So when you write from logarithmic form to exponential form, what I want you to think is same, change, change. So for example, if I give a logarithmic expression, log base 9 of 81 equals 2, we can write this in exponential form. Think same, change, change. So write the 9 first, change the 2 to an exponent, and change the 81 on the other side of the equal sign. So keep the 9 in the same position, change, change. So let's look at some more examples in the notes packet. So here for example 1a, we have log base 2 of 16 equals 4. This is the logarithmic form. To change it in exponential, think same, change the 4, and change the 16. Same, change, change. So 2 to the 4th equals 16, or log base 2 of 16 equals 4. Let's look at b. Here we have logarithmic form, so for exponential form, think same, change, change. The 0 and the 1 switch positions. Let's look at c. You're going to keep the first 12 the same, change the 1, and change the 12. d. Carry down the 1/4, and you're going to swap the negative 1 and the 4. Now let's look at example 2, where we're going to rewrite the other way. So in example 2a, we have our exponential form, 5 squared equals 25. So logarithmic form, write the word log, your base is the first number 5, and then you're going to swap the 2 and the 25. For b, our exponential form is given, so write log, keep the first number the same, and you actually drop it down a little bit lower, and then swap the 0.1 and the negative 1. So for c, log base 8 of 4 equals 2/3. d, log base 6 of 1 over 2/16 equals -3. Again, notice these two switch. The 6 stays, just drop it down. Notice log base b of 1 will always equal 0 because anything to the 0 power is 1. Also, log base b of itself b will equal 1 because notice b to the first equals b, or itself. Now let's look at example 3, evaluating logarithmic expressions. What we're going to need to do is make common bases. Make common bases. So, step 1, equal it to x. Step 2, rewrite. So write it as 4 to the x equals 64. Step 3, make common bases. So 4 or 64 can be written as a base of 4. 64 is 4 to what power? 4 to the 3rd. And then your last step is solve for x. So notice x is in the exponent, so is 3. So you set the exponents equal to each other. Once the bases are the same, you can kind of drop them out and set the exponents equal to each other, so x equals 3. Let's try b. Step 1, equal it to x. Step 2, rewrite in exponential form. 5 to the x equals 0.2. Make common bases. So let's use a common base of 5. 0.2 really is 1/5, and we can bring that 5 up, but the power will become negative. And now that we have common bases, we can drop, and we'll see that x equals -1. Part C, equal it to x. Rewrite in exponential form. So I have 1/5 to the x equals 1/25. So both 5 and 1/25, think about what base we can use. Let's use 5. 1/5 brought to the numerator makes its exponent negative, and it already has an x there, so we now have a negative x. 1/25 can be written as 5 cubed. So now drop your bases. If negative x equals 3, divide both sides by -1, and x will equal 3. Last one. Equal this to x. Recopy. 36 to the x equals 6. 36 can be written down to a base of 6, 6 squared. But it already had an x there, so now I have 6 to the 2x. You multiply the 2 and the x together. And right now, the 6 on the right has a power of 1. So drop the bases. I have 2x equals 1, or divide both sides by 2, x will equal 1/2. The last example, you're simply typing these numbers into your calculator. So for example 4a, log base 8. So you'll notice log, you'll have to hit Control, the 10x button. If there is no number at the bottom, if there is no number on the bottom, the calculator will automatically place a base of 10, which is what we wanted to do there. So the answer for A would be, if 3 decimal places, 0.903. Let's try ln of 0.3. Again, you're going to have to need to hit Control, then the ln button, and then 0.3. And you can see your answer will be -1.204 if we round correctly. And that is it.